Welcome to my talk. My name is Jakob Unterwurzacher, and I'm the author of gocryptfs, which is a transparent encrypting file system. I will go about what it is, what it does, a short how to use it, a bit of history about gocryptfs, and how Go made it easier to get this project done. So let's start with the basics. The name, it's not very creative, but this is what it means. It is an encrypted file system written in Go. So that's what gocryptfs is. What does it do? What is it? Part 2. It's a file encryption solution. It works on Linux, which is where it is primarily developed. It also works on Mac, and there is a third-party port written in C++, which is why it's called CPP cryptfs, which works on Windows. It's an open source project on GitHub, MIT licensed, and it's transparent encryption, which means that you can use it like any other file system. It's like a regular folder. You can store files there, and they will be transparently encrypted on your disk. The goal and motto of gocryptfs is simple, secure, fast. We will see if I achieve this goal. So what does it do? I will revisit that in a live demo shortly. With gocryptfs, you have two folders. One is this is the folder on the right, is where the files are actually stored on disk. Then gocryptfs generates a plain text view of this encrypted folder. This is called my files here, and as indicated here, when you put files or folders in here, they will appear on the encrypted side. And as you see, the file names are just a bunch of garbage because these are encrypted together with the file content. I will make a short live demo to show you how to use it. So we will make my files encrypted, and then you have to initialize the encrypted folder. This will generate the config file where the master key is stored. You choose a password. I will just use test here. Then it prints this very important message that you should read, and you should save or print out your master key, because this will help you recover your files when you forget your password. Okay, created successfully. You can now mount it using gocryptfs my files encrypted mount point. So that's what I'm gonna do. My files, and that's it. I will open both folders now. So this is okay. So as we have seen before, this is maybe I can get this a little bigger. This is where the actual files are stored. At the moment, we just have this config file, which is it's a JSON file that stores the encrypted master key and some settings, and an internal random seed, which is not important here. And this is the encrypted view. And when I make a new folder, you see that it appears on the other side. That's it basically. Now we can unmount. We can unmount this folder, and then the decrypted view is gone, and you need the password again to unlock this. Okay. Interesting. Okay, that was the short live demo. What do you use it for? You can use it to store your files and have them still easily accessible. Store them on an untrusted medium. For example, you can put it on your Dropbox, or have an encrypted folder on your laptop, or upload your files in an encrypted way from Google Drive. But of course, I basically have no idea what it is used for. I just get little bits of information from GitHub tickets. This was pretty interesting. This was a GitHub ticket from a user who uses it on Google Drive. He wanted to know how to decrypt the file names so he can organize his stuff without decrypting and downloading everything. And it turns out that he has 1.2 petabytes of data on Google Drive encrypted with gocryptfs, which I found pretty nice. Now for the short history of gocryptfs. I started contributing to encryptfs, which is a similar project. It is written in C++, and I found the code quite complicated, so I got the idea of starting a new project. And I also found Go, which looked like the perfect match. On 2015, I pushed the first code to GitHub. 2016, a motivated person started a Windows port of gocryptfs written in C++, which is why it is called cppcryptfs. I think it works fine nowadays. I reached 1.0 at some time, and then looks like the company 23andMe got interested in gocryptfs. Do you know what it is? 23andMe? I will maybe just click it for people who don't. They are a genetic testing company. So they sponsored a security consulting firm to look at the security of gocryptfs. It was performed by Taylor Hornby and was generally favorable. He found possible weaknesses which were subsequently fixed. But in the end, I have no idea if they chose to use gocryptfs or not. A few months later, I released the first version that is actually faster than encryptfs, which always was the goal. And over the years, gocryptfs got included in the package repositories of basically all the major distribution, and even in homebrew for macOS. And it has come to my attention that there's even talks about gocryptfs now. So the underlying technology that gocryptfs uses is called Fuse. It's the Filesystem in USErspace protocol, which was originally developed for Linux. It is also available on macOS and on FreeBSD. And Windows has something similar, but it is much younger and not as well integrated. What happens here is that a user application, for example, wants to create a directory. It asks the Linux kernel to create this directory for a system call, and then the Linux kernel forwards it to a special file, which is called dev.fuse, and it sends the mkdir photos command through the Fuse protocol. And this ends up in the gocryptfs file system and is handled here. Other notable Fuse file systems that you have maybe heard about are SSHFS or even the Linux NTFS, the Windows file system driver for Linux, uses Fuse. So the Fuse protocol is no fun to parse. It's pretty complex. I would say that it's more complex than HTTP. It has sequence numbers, parallel streams. Everything is addressed by node numbers instead of paths. But fortunately, there's a very good Fuse library, which is called gofuse. And gofuse parses this Fuse protocol stream and gives us a normal Go function call where the file name is, in this case, the file name is just passed as a parameter. Then gocryptfs receives this function call, encrypts the file name, and writes it to disk. The reference implementation is called libfuse, and this is developed in lockstep with the Linux kernel. So it's also a bit of work to keep those two in sync, but fortunately there's a maintainer of gofuse who does a pretty good job. So as I said, gocryptfs encrypts both the content and the file names. Let's say the user wants to make the directory photos. Gofuse translates this into a function call, into gocryptfs, and then we actually create the directory with some random garbage name in the backing directory. So I use a somewhat not too widely used algorithm, which is called encrypt mix encrypt, where I wrote the implementation myself. This was also criticized in the security audit. However, I have test data. I did not specify the algorithm myself. Those two pretty famous people, Halevi and Rogaway, did, and they also in the paper they also provided test data to validate that the implementation is correct. And of course, there's a test for that. So I think it's fine. Okay. For file content, we use the AES GCM algorithm because it's very fast. And of course, to allow random offset, you have to segment the file into 4 kilobytes and stuff. If you want all the details, it's on the gocryptfs website. By the way, the last slide will be a link section that is references to all the projects that are mentioned. Testing. So losing user data always is a big deal. So that's what the file system implementation always wants to avoid. What I did to avoid it is to have tests and also make them easy to run. I have what I call a one-click test suite. It's called test.bash. You execute it. It doesn't take any parameters. You don't have to set up anything, and it just does its thing. It runs the tests, and in 21 seconds, which includes the compilation, it's done. I also have a bunch of stress test scripts. They run indefinitely in the stress test folder, and also those. Everything is one click. You just execute it. You don't need any parameters, and it just does its thing. If it's annoying to start the tests, you just will not run them, I think. Then what I also found important is to not only have your own tests, but to have an external test suite. Fortunately, there is xfstests for Linux. It's like the standard test suite. It is also tested. It is also used for testing the normal Linux file systems. So what I did is I made my own fork. I called it Fuse xfstests, which is basically the xfstests extended to also support testing gocryptfs. And of course, I added a one-click script that you execute and it runs the tests. The good thing about an external test suite is that they test things that you probably didn't even know about that they exist. And xfstests does that. And it found bugs in gocryptfs, of course, in the gofuse library, and even in the Linux kernel. That one was interesting. How to get your project to run fast? I think it's important if you want it, if you need that. It's important to have benchmarks and to make it easy to run them. And of course, there's a one-click script which is called benchmark.bash. And also, gocryptfs has this integrated profiling and tracing. You can enable it through command line flags. This is all standard library functionality. You pass those flags, and it will write the data you can analyze to those files, and you see where your problems are, where you spend most of the time. Then what was also pretty helpful is to have for the critical path for gocryptfs, that's encryption, to have a very simple speed test included. Maybe I can show it quickly, what it does. So it doesn't look too interesting in itself. It just compares two different implementations of the encryption. The one is in the standard library, and the other is OpenSSL. This is not too interesting in itself, but to have this enabled users to run it easily on different CPUs, and somebody started a wiki page recording the results for different CPUs, which was pretty interesting. As I mentioned, one of the goals was to get gocryptfs running faster than the grandfather, encryptfs. Of course, what helps here is that I use the AES GCM algorithm, which is very fast and was not available at the time that encryptfs was written. Then what I also do is that I reuse the data buffers that I allocate. As you may know, as you may be aware, Go is a garbage collected language. So when you ask, give me a buffer of 1 megabyte, then you use it, and then you stop using it, and then you get the next one. Then the garbage allocator has to clean up after you. Sync pool is a way to save this buffer for later use. You lose a few advantages that the garbage collector provides, so only do it if the profiles that you should be looking at tell you that you need it, I think. Then also the library is very efficient, and Go made it very easy to parallelize the encryption into 2 threads. Then there's cases where pure Go is not fast enough. I've mentioned that I use a very fast algorithm for encryption, which is GCM. And the Go library has a hand-optimized version of this. Written in assembly, it's super fast, but it only exists for 64-bit PC CPUs that have crypto acceleration. The PC I was working on, the PC I was developing gocryptfs on, did not have this crypto acceleration, which was a pretty big motivation to try to get it to run faster. And this was to use OpenSSL, because OpenSSL has optimized implementations for basically all the crypto algorithms built in for every CPU out there. And gocryptfs on startup detects if your CPU has this and decides what to use. And I called a and I wrote a minimal wrapper around OpenSSL, like language bindings for Go. It's called stupid GCM. It was not that bad, and stupid GCM is called stupid because it only does what gocryptfs really needs, and if you pass other parameters, other key lengths, different node sizes, it will just panic and crash your application. But it otherwise works fine. Okay, last slide. When I started thinking about, or when I was working on encryptfs, which was written in, which is still written in C++, the code was very convoluted, and I originally planned to rewrite it in C because I find C easier to understand. But then I discovered Go, which was C, but somehow better in every way, and that's what I chose. And I think having it in Go helped to have easier code, have easier testing, and easier profiling, and it also still provided the tools to call into C libraries like OpenSSL, and also to do, I mentioned syscalls here. It also allowed me to use functions in the Linux kernel that are not available through the Go standard library. So all this is possible in Go. It runs pretty fast, and I would definitely recommend it. I would definitely choose it again. So this is the literature slide I promised for later if you download the slides, and that's it. Thank you for your attention. And